Okay, we have quite a lot of ground here to cover today, so let us kick off. So many thanks everybody for attending today's INEMI Roadmap webinar. Today we're going to review the existing content in the Sustainable Electronics Roadmap. That will be presented by the two co-chairs for the team that have created that content. So that is Thomas Okrasinski from Nokia and Zhao from Purdue University. We'll spend about 35 minutes or so on that and allow for about 5 minutes of Q&A and or discussion. Before getting on to the second part of the session, where we will give you an idea of what are the next areas that we're going to be working on in the Sustainable Electronics Roadmap, specifically in the area of ecological footprint in PCB manufacturing board assembly. We'll have a little bit of brainstorming and a little bit of discussion around that. And I will be looking after that part. Myself and Linda Wilson, the INEMI Roadmap Manager, will be looking after that part. I should point out that the two things. One, the content that you are seeing is actually all available online. Linda has already put into the chat the link to that content, so feel free at any point to go online and have a look at that. And the intent is we will publish, as we complete various bits and pieces, we will publish additional content there over time. The second point I want to make is a purely administrative one, namely that we are recording this session because we need to be able to reuse this webinar for other purposes. So, and it will become available publicly in due course. So with those preliminaries out of the way, I'd like to hand it over to Tom and Fu to do the review.
Okay, thank you, Frank. All right, so let me start off just by talking about the scope of sustainability shown here. We have a Venn diagram on the left there that shows the scope of sustainability as 3 overlapping circles. This kind of illustrates the relationship between the planet, people, and prosperity. And of course, sustainability is a balance of these 3 key dimensions: planet for environmental sustainability, people for social, and prosperity for economic sustainability. These 3 aspects are interconnected, and they form a holistic approach to sustainability. And a key insight is that economic viability is closely intertwined with environmental and social impact, as shown here. Next slide, Frank. So on this slide, we talk about the key stakeholders in relationship to sustainability. And of course, from an external driver standpoint, they include, of course, our customers and end users of the products and the services that we produce, the shareholders that are investing in our companies and entities, and then regulatory agencies and governments in which we work and participate and are governed by. And then within the industry, they include the OEMs, the original equipment manufacturers, of course, and the electronic manufacturing services, or the EMSs, the component and material suppliers, obviously, who make the myriad materials and components that go into our products. And then at end of life, the reusers, the refurbishers, and the recyclers, all working to then have these materials being used back into the supply chain as much as we can. Next slide, Frank. So just a quick overview on the road mapping part for sustainable electronics. Here we show the INEMI Sustainable Roadmap and what's most recently published on the topics. There is the published overview, starting with that on the left, given you an overview and a discussion about sustainable electronic solutions. And then in the manufacturing area, there are the subject areas of responsible supply chain, materials and toxicity, energy, water, and land footprint. And these roadmaps collectively are published, and they include the materials, strategic materials, plus the PCBs, and which is the printed circuit boards, and then the materials tables themselves. And in the area of end of life, it includes published roadmap on circularity, which covers things on the 9 Rs, reduce, reuse, repair, refurbish, etc. So at this point, I'm going to turn it over to Fu Zhao, who's going to give us a more detailed discussion about the materials roadmap. And then I'll be back later to talk about the circularity roadmap. So Fu, over to you.
Okay, thank you, Tom. Okay, if you think about the electronics industry, we are dealing a huge amount of materials, right? All kinds of things. For example, take your cell phone as an example. People claim there are more than 70 elements showing up there, and some people may be saying even like more than 80 different elements. So that's just the elements out of the elemental periodical table. And, we certainly also have compounds there, right, to make the material mix very, very complicated. And the material used there could have potential environmental impact, and certainly they also have economic and social impact, just because we have pretty long supply chain. So think about the industry. So when industry is facing issues or challenges, in the past, the response is mainly reactive. Okay, so for example, right now we are talking about the extending the use of digital product passports, especially in Europe, and also PFAS is another hot topic. And we have ongoing regulatory push to phase out PFAS in many products, including electronics. But those are, reactive and may not be the best or ideal approach. Many times, if you stay reactive, you may not be able to find the best solution. You may waste a lot of, efforts and resource and also money. So here, we are talking about maybe it's better to go proactive. Okay, so that means industry should build sustainability consideration into product design and manufacturing before, there's a regulation. So to do this, we need to proactively identify future issues for, existing materials. If, okay, you want to introduce a new material or use a new material, we better evaluate the potential environmental impact, and you should try to avoid, ecotoxicity and certainly also human toxicity. And greenhouse gas emission, you want to evaluate the carbon footprint of the new material and make sure it's better than the existing ones. And another thing is we have to consider end of life management. So adding new material will make the mix even more complicated. It may hinder, recyclability, and that means more material may get wasted or end up in the landfill. So again, when you try to introduce new material, make sure consider ecotoxicity, human toxicity, consider carbon footprint, and also make sure the new material will contribute to improved circularity, not reduce the circularity. Next one, please. So how do we manage material use in the entire supply chain? At the bottom of this slide, we so a very simplified, supply chain, and we start from raw material extraction, and we have material supplier in the middle, and finally, um, we have the companies there to actually assemble components together and to make the final product. So the supply chain can be complicated, can be very long, and involve many OEMs. So here, think about the global scale. Okay, industry has to consider. Okay, how do we ensure the availability and control of some critical materials? And for example, rare earth elements. So right now, China still dominates the production. And recently, there are also concerns raised about gallium and selenium, right? So these two are commonly used as semiconductor material. So very important to electronic industry. So again, all these, critical materials, okay, they are critical because they are important, but at the same time, we worry about potential supply chain disruption. So many times, so the production is concentrated. So, the challenge here is to build a secure and also socially responsible supply chain. The socially responsible supply chain, that's not really a new idea. So in the past 10, 20 years, we heard the term, uh, for example, conflict material, right? So talking about cobalt from DR Congo. And now we have to consider the secured supply chain, right, to avoid disruption. For example, in the case of rare earths and gallium and selenium, right? But also keep in mind, electronics, for many of those critical materials, electronic industry only use a small portion of the total production. So basically, we need a common industry voice to aid cross supply chain coordination. For example, nickel. So electronics, okay, we have tiny bit of nickel there, but we have lots of nickel used to make alloy and also EV batteries. So electronics industry is a small player. That's why we argue we need a common voice, right? So basically, we show our concern and make sure our voice is heard. And also, um, digital product hotspot, especially in Europe, this is being pushed by uh, the regulation bodies. And the key here is, when you make a component, a product, you need to disclose the material composition information. So, with this information, recyclers can do a better job and to improve material recovery rate. Next one, please. Okay, here comes the big table we built for the roadmap. As you can see here, we have two examples. One is epoxy resins. The other is, sulfuric acid. And both are very important for PCB manufacturing. And then first, okay, we check on the amount used, and then check on potential recovery value, high or low, and then check on material availability, and then whether or not, electronic use is a major player, okay, and in many cases, no. And responsible material extraction, as I mentioned, okay, so the case of cobalt, right? Okay, so it's from DR Congo, so we have, some social issues there. And then we have to consider the eco perspective, whether or not they are toxic. And then, okay, finally, also check on whether those, material are reportable. And going along, okay, you see the circularity pathways. Okay, we check on reuse and refurbish and recycle. And toward the end of each row, we want to evaluate the technology readiness level of the technology. And also we try to make a projection, from, well, 2023 when we started doing the roadmap, and we want to have a 10-year time frame projection down the road. And certainly here you can see talking about, reduce, reuse, recycle, and replace, all those options. And we have technologies available now, or we have good reason to believe, okay, they will be available in 10 years. So overall, this table is a big one, very long. We try to cover all the key elements and key compounds, and certainly including critical materials. And for PFAS, we plan to have a separate table, and that one is in progress. Next one, please. So for the material section, in summary, okay, we made some argument at the material science level in the homogenization of regulation and also at the supply chain level. So first, material science. We need to have better understanding of how material is used and their eco impact. And second, drive the development of a new material and process for material substitution. Okay, so here we are talking about new material, and we need to make sure, okay, we will not create new problems. And then talking about the regulation. So right now, if you think about the US and versus EU, we have very different approach regarding regulation. And even US different states, they have quite different approach. For example, PFAS, I think, California has the strongest, and I mean, Indiana probably we don't have much here. So to have a level playing field, okay, we need to have some kind of homogenization. But this won't be easy. But we have to pursue this, and otherwise we will put small and medium-sized companies in disadvantage. We may push them out of business. And the supply chain side, okay, digital product passport. That's a very important tool, and that will enhance the sustainability, and through the supply chain visibility. And last one, we need to collaborate in order to support, a nice and sustainable supply chain, right? So we want to trace and have global audits on conflict mineral and materials. And again, coming back to the example of cobalt from Congo, and we may have other materials there, right? So years ago, I read an article about tin production in Malaysia. Okay, so similar social issue. I think that's all we have for materials, and now I've handle it back to Tom to talk about circularity.
Yeah, and let me stress, if there are questions, we're going to hold them until after I talk about circularity, and then Fu and I will cover anything that you have on both roadmap areas. So here's the key principles for circularity. As a similar exercise, the members looked at what are the key principles. So shown here, we see from the Ellen MacArthur famous drawing, their foundation, the butterfly diagram. The electronics goods technical cycle can be envisioned here as you see a series of loops throughout the life cycle stages. And the objectives are clearly to maximize renewables, minimize finite raw materials used throughout the life cycle, and minimize disposal, and of course, its negative ecosystem impacts. And those principles, as you see to the right in the green box, can be applied along this life cycle path. And of course, they include design for longevity, reuse and repair, remanufacturing, recycling, resource efficiency, sharing the economy, leasing models, anything in which it's just not sole ownership and that multiple people can share in or multiple users can share in. Bio-based materials and also with bio and geodiversity in mind, and then intelligent digital solutions. What we can do to maximize the marketplace and the reselling or redistribution and reuse of equipment. And I'll get into a little bit of that in a further slide. Next slide, Frank. So in a similar exercise, we did the technology readiness level for the various solutions that we saw in this area. It's in relation to technology for separation in recycling. And again, we're looking at the time frame from current to when we did it. It was a decade out. So at that point, 2023 to 2033, as you see here. In the first row, the regulations and industry standards. We expect progress from development, shown in yellow there, to full deployment, shown in green, by the end of the 2033 period, shown here. This is being pushed and promoted by the development and eventual rollout of for instance, the European Union Digital Product Passport, where for electronics deployment is anticipated in the latter years of this decade. And particularly, you'll see it for batteries starting, and then eventually for other electronics. In the AI-based full spectrum inspection for materials in the products, this is currently more in the research phase, shown in red there, but we anticipate this to be in full deployment by 2033. So progress from research through development to deployment. And in the combination of robotics and AI for electronics disassembly, we expect a move from the current development to deployment in this decade going forward. So good technology advancement there. Global deployment of new separation technologies. Much is needed there to guarantee it's not just in one country or region, but spread out. We expect that to follow a trajectory very similar with full deployment over the next 8 years to 2033. So it will take time to establish that and push that out in the regions where there is a deficit right now, not having those technologies. Key takeaway from this slide is that while most technologies are in development now, advancements in both AI and robotics, we feel, can drive significant improvements in e-waste recycling and also with global deployment, which we anticipate early in the coming decade or possibly sooner in the late time frame of 2028, 2029. Next slide, Frank. So in the new market structures and business models area, 4 areas we put here for solutions. First, in the recycling and reuse marketplace, a verifiable marketplace for enterprise-grade equipment is currently in development, TR6, and we expect this to be fully deployed very soon, by 2026, so well along its way. In the electronics as a service, one in which we have leasing models for high-end electronics. We see that also in development now, and companies considering rollouts of this with deployment projected by 2028, 2029. In the reverse logistics for international shipments, so trying to get products back and having them shipped cross-boundary. The network carriers involved in this are already looking to have this as more of a mature business model. And we should see more fully optimized models here rolling out 2028 and later. And in sustainable microelectronics awareness, we see this is currently in an early research phase, only TRL2, as we show here with the red, but expect this to reach full deployment very rapidly thereafter. due to promoting right to repair and also with recycling initiatives, which we feel which will come about very quickly. Key takeaways from here is we see strong industry momentum towards sustainable business models. Some solutions are closer to deployment, such as marketplace leasing, logistics, while others will need more investment, such as consumer awareness. By the end of this period, 2033, most solutions will be fully deployed, we feel, supporting a more robust circular economy for electronics. Next slide, Frank. In this one, we look at the design and test for repair, reuse, and recycle. The current technologies and design practices are already available to provide for modular designs, hot swappability, easier chip replacement, and for remote software updates and downloads, especially for business-to-business type products in the environment there. In the right to repair, development is well along for modular designs that we feel that can achieve increased integration, functionality, and physical integrity with deployment we foresee starting in around 2028. From the reliability testing standards that are backed by modeling and testing methods, this is in full development right now with deployment we envision starting around 2028. Next slide, Frank. So what are the key recommendations in the area of circularity that's shown in our roadmap? First, establish and standardize metrics and methodologies that are suitable for circularity of electronics. Those standards are much needed, and once we have that in place, many can then follow suit and use those as deployment minimum platforms in which to invest money on. R&D needs to support cost-effective reuse, remanufacturing, and recycling. It needs to focus on finding pathways for components that are currently unusable or unrecyclable. Tackle those and find out what are the means in which we can overcome the barriers and the thresholds. We also need to extend current collection and recycling networks, making more economical systems available at the local level, where you don't have to then transport things, products far away or internationally. Try to do it more locally. Make circularity a key component of manufacturing business model. Here, a consumer shift from product-oriented to service-oriented business models will need to happen. And an example of this is electronics as a service, providing that on a more common basis. And develop supporting tool capabilities, both hardware and software, for product design for circularity. Now, one example we mentioned is a more open and transparent and digitally driven marketplace, one built, let's say, on blockchain, in which you can get advertising of product and materials that are becoming available for reuse, or it's reached its time where it cannot be reused further because newer technologies are better, more energy and materials efficient, so ready for recycling. And in which case you can offer that digital exchange platform for such used electronic equipment and components. And lastly, but most importantly, create a single and strong industry voice that promotes sustainable electronics practices to both the public and the consumers at large. This, we feel, is a very, very important step. So what I'm going to do now is open it up to questions, since Fu and I have given you quite a bit of information, but we'll see what we can address here in the next 5 or 10 minutes. So a question about, I think, proposing going across borders and states, et cetera. Again, I think in that case, again, it's trying to make more transparent what is available, what is there that can be exchanged, what the value of those components and materials can be, and what can happen as far as making an exchange to move that into another region or territory, making that information available so people can either bid on things or promote trying to get that exchange of equipment.
So, Tom, there are a variety of questions in the Q&A if you wanted to check them out.
Okay.
I just see
Yeah.
there's from Andy and Kieran and Akil, several about materials and digital product passport.
And also, there's a very interesting one. Okay, growth may not be sustainable, right? So I know some people are talking about degrowth. So yeah, I kind of agree. So until now, we haven't really figured out a way to decouple economic growth and environmental sustainability. So yeah, good question. And clearly, we don't have an answer to that.
Yeah, I think the one question about regulations going forward and what's going to happen in a deregulated, politically motivated world in which we live in now, when we have put these roadmaps together, obviously, kind of a year ago, a little bit different in the timing, but yes, challenges will come about from that. But a lot of this in circularity is driven by economics and also driven by what our customers are demanding. So not political per se, but more of what the end users want to see. And we focus on that mostly and try to address those in our programs and what we do from a circular standpoint. Politically, yes, can change regulations and affect some of those economics. And that has to be, obviously, we have to be cognizant of that and what's happening and how that those regulations are indeed changing. So updates to the roadmap clearly will need to happen.
Yeah, Tom and Fu, can you read out the questions that you're answering? Because there's quite a lot here, and some in the chat and some in the Q&A. So just to keep everyone aligned, that would be great. Thanks.
Okay, so let's take another good one here. Where do you see the reuse of chips, either through desoldering or use of debondable conductive adhesives, e.g. Intotech? Tom, I think this is one you've given some thought on.
Yeah. So removal of chips is clearly one that, again, the market for different types of ICs, et cetera, whether they're just more of the standard chipsets that can be used in many, many products and in different industries, will clearly have a market advantage for trying to remove them, test them, show their reliability is still there, and then remarket and repurpose them again. I think that will be driven. The more custom ASICs can be a challenge because they're more driven by a specific need. And that's something that would be, I think, a little bit harder than to remove and then redeploy again. But clearly, in more common standardized equipment types, I think there can be a better market driven for chip reuse there. And so that can follow.
Okay, another question here. What is the nature of the digital passport? As a material supplier of liquids, pastes, and discrete pieces, how can this apply?
So I can take this because I work for Nokia and we're in the European market, and digital passport is coming very quickly there. I mean, obviously, it's coming about first in the battery area. This will be one of the earlier ones in which we'll have the guidance and the regulations pertaining to the digital product passport there. And the objective there, I think, is to see how we can get all of the necessary information up front in the supply chain built into these platforms that will come about now. So we'll be learning a lot from the battery platform and how that's going to come about. And then other electronics, I think, will ensue probably by late this decade, 2030 timeframe is what we see for other types of electronics. Got to remember that the digital product passport is not just for electronics, it's also for other things. So fabrics, for instance, and textiles, they'll be doing an initial DPP for that as well, along with batteries.
Okay, another question here. There are existing standards for circularity, including from ISO and UL. What are your plans related to creating standards? I should point out that INEMI does not in itself create standards, but we do work with other organizations to inspire them and to provide contributions to them to do so. But in terms of where ISO, UL are on circularity, Tom, do you have any comments in terms of what else may be needed, for example?
Yeah, in electronics area, ITU, the International Telecommunications Union, has their L.1410, which, for instance, is life cycle assessment for ICT products, communications technologies products. What they've done is recently updated their L.1410 spec to include circularity. Because of the needs right now that we have to do that, to address how you look at that, how you take credit for extending the product life cycle, how do you take credit for a refurbished, remanufactured product, in looking at the life cycle impact of it. So those are examples of some that are starting to happen, and we'll be seeing others developing as well this year and in the coming years.
Okay, and another one on regulations, etc. How does this roadmap reflect ESP or eco design for sustainable product regulation requirements? What are the overlaps in terms of the thinking here?
Yeah, from a material side, I can let Fu talk about that, but from a circularity standpoint, how much recycled content, for instance, that's going into products today is now being measured and having to be reported at an annual level by companies, at least regarding the Corporate Social Responsibility Directive, the CSRD in Europe. We, as a company, Nokia, has to report how much recycled content is going into their products now across the company. And that has to be done on an annual basis. We're going to see more of the materials disclosure and also recyclability and recycled content information having to be disclosed going forward.
And another thing I want to point out is, yes, we are facing some uncertainties regarding the change of, administration. But from company perspective, Tom, please correct if I'm wrong. So I think look at the Europe, right? So I don't believe Europe will stop their pursuit of environmental sustainability, and they will continue with a relatively strong regulation. So it's hard to believe company wants to maintain two separate supply chains, right? That will be quite expensive to do. But you can certainly argue even Europe is moving toward the conservative side. Well, that's another thing.
Yes.
Okay, and I'm going to take one final question, and my apologies. I know there's more stacked up here, but we and I really appreciate the level of engagement here. But let's take this one from Jeff Kettle. Could you provide more information into reliability testing standards, Is this particular for repaired electronics? What work has been done about reliability around modular electronics design?
Fu, can you address reliability more in materials and those issues on electronics?
So here we are talking about okay, repaired electronics, right? Well, certainly, you know, if you try to repair anything, you have to do testing, right, to make sure, you know, they meet the customer requirement, and they may be also a warranty issue. I'm not very familiar with those testing standards, but I assume they are somewhere, okay, and you know, the companies doing this kind of work will need to follow. Again, I stay in academia, so you know, I really don't know what's happening, you know, out there.
Guys, can I take that question? Often, if, I work a lot with the automotive industry. Many of you may be aware. I work on the AE scene with others, and very often those kinds of considerations about reusing components and so on are taken care of by the fact that they use a 3 pre-con reflows as part of the protocol for before we start doing reliability testing. So it's often the case that 3 or sometimes 5 reflow cycles are given to a component, so that if it is reused and reconditioned and reused and so on, that is actually part of the consideration of the final reliability of the device. So that's kind of built in.
So the standards you're saying, Andy, are now being updated to account for repairability and recyclability?
No, sir. It always has. It always has been. Certainly in the automotive industry, the 3 pre-con cycles is already built into it. It's actually in J standard 20 as well.
Okay, yeah. So that's not my area expertise. I apologize, but
No,
yes,
not
here.
at all.
Mhm.
And indeed, this is a very wide domain. Look, many thanks for the engagement here. It's been excellent, folks. Apologies, we do have a little bit extra on the agenda here today, so I'd like to push on. Of course, feel free to reach out to Tom, Fu, or myself if you want to engage further on this, on these topics, or indeed have any feedback for the material that is there in these 2 existing areas of circularity and materials. We're always looking for alternative perspectives, corrections, updates. It's an online format. It's something we can change relatively quickly if there is, you know, a good insight comes into us that we feel should be reflected in the online material.